Okay, first functor I want to talk about is the map functor. And as I mentioned in the whiteboard lecture, map takes a list and applies a function to every element of that list. So let's look at some of that sort of implementation before we get to map, right? What is map replacing? So for instance, we could say have a function called double every element. Takes in a list, returns a list that's hopefully has every element doubled. How would we do this normally? Well, we'd have some sort of accumulator list, right? There's going to be a list of ints, and it's the empty list. Then I need to do a for loop. So for every element in my list, what do I want to do? I want to take acklist and add on the back of it, right? Since I'm thinking about walking through my list from the head to the tail. So my accumulated list is going to be the first chunk of terms, and then I want to add on the next possible term. I'm going to do this list of 2 times element. And then what do I want to do? I want to return my accumulator. So let's see if this compiles and runs. I need the for terminology in Scala is the single line arrow. So this pulls out every element of the list and concatenates on the back. Oops, sorry, I want to update acklist. And that means that this needs to be a var as well. Cool, that seemed to have done exactly what we wanted. A couple of little details here. Since I'm appending at the end of the list, what I'm really doing here is using the plus operator, which is the concatenation operator. So it takes 2 lists and combines them together. So what I'm doing is I'm turning 2 times the element, right, this back list, or this back element, into a single element list, and then I'm concatenating the 2 lists together. Right, so don't get confused between this and, say, the cons operator, right, the double colons. The double colons will take a element and append it onto the head of a list, right? And since under the hood this is essentially a linked list, this is very optimized to do, right? We're just sort of adding a little extra element and a pointer to the old list. And then I can combine 2 lists with the double plus plus, the concatenation list. So that's what we're doing here. And this works, right? We could also do this recursively. How do I do this recursively? Well, I want to be able to pull out all of the elements of my list, right? Or at least pull out one element and then the rest of it so I can recurse down on it. So I'm going to do that using a case match statement. So I'm going to match for my list. So we can have the case, well, if it's nil, right, so it's the empty list, then I will just return nil. Otherwise, I have something that looks like head, colon, colon, tail. Okay, and what do I want to do here? Well, I want to double every element. So I'm going to do 2 times head and then append that onto double every element recursive on tail. Let's see if that works correctly. Yeah, we get 4, 6, 8. So this is cool, although notice that this is not actually tail recursive, right? If I wanted to make this tail recursive, I could add a block of code here. And then, right, what's actually going on here? I have val final tail. This is actually double of tail. And then really what I'm doing is I'm returning 2 times head with final tail attached to the end of it. So this is equivalent to what I had just previously written, but it's much more clear that it's not tail recursive. So how would I do this as a tail recursive function? Well, I want to add an accumulator list. This is going to be a list of ints, and I'm going to set this as a default of nil, right? So when it first starts, it's just nil. I can leave the accumulator list out of it. And now what I'm going to do is, well, if I have nil, then I want to return not just nil, but the accumulator list. Again, I have the case when I have a head and tail. And now what I want to do is just do a double every element recursively on, well, what list do I want to do? I want to apply it to tail. And now I want to take 2 times head and : backlist. Sorry, backlist is going to start building from the front forward, right? So I really want to do backlist plus list of 2 times head. And I get the same answer. So this is the tail recursive form, right? Okay, so that's cool. How will we do this using a map, right? So we had our for loop, we had our recursive definition. Now let's see how we can do this with map. So this is just list.map. And then what do I want to do to every element? I said I wanted to double it, right? So we already talked a little bit with the anonymous functions. So we could do something like underscore times 2. And that works, right? So you can see how much faster or how much maybe cleaner, depends on how you like to look at it. Right? This is a very simple way to say the exact same thing. Right? I don't have to do any of the manipulations. I don't have to do any of the accumulations. I just say this is the function I want to run. Multiply the value by 2. And it returns a list that does that. If I want to be a little clearer about this, right, one thing I could do is to say x and then turn this into x times 2. Right, this is a little more explicit in my anonymous function, but it's equivalent, right? Whichever one is maybe easier for you to read. But this is how we use maps. And we can, of course, mix and match types. We can do all sorts of things. Basically, any function we can run, we can pass to a map and have it apply to our elements as long as the function takes whatever type our elements are. Right, so for instance, we could say, do this, right? We're going to take an input, which is a list of ints, and I want to append hello to the front of them of each int and return a list of strings. So how would we do this? Well, I'm going to take list, I'm going to apply a map, and what do I want to do? I want to take my x, right, my element, and I want to append hello to the front. So one way we could do this is do hello $x. And we see that we have hello with all the numbers attached to the front. This is a really useful way to do putting in variables into strings, right? So the S tells Scala that to look out for $, variable names or value names. And when it sees $x, it says, is X in my environment? And if so, replace it with whatever X is equivalent to. And so that's what this is doing right here. So yeah, anytime you have a function, you can always pass it to map. You can also give it named functions, right? So maybe I want to say, instead of this, I want to say def times 2, and it takes an int and returns an int. And what does it do? It just takes x times 2. And then inside of my map here, instead of this anonymous function, I now can just put in times 2. And this still works, right? So we can give names to the functions that we pass in, or if it's simple enough, we can just write an anonymous function. And map takes that function and just applies it to every element of our list and returns that list. Yeah, so that's how we do this in Scala.